Number 17, we need to find the exact zeros in simplest form of a quadratic function, both algebraically and with technology. So let's look at number 17. We have negative 2x squared plus 8 thirds x plus 32 ninths. So I'm going to find the exact zeros algebraically first, and then we'll look at it with a graph. So referring back to this sheet, we do have standard form. And how do we find the zeros? Set the output to 0, then either complete the square or use the quadratic formula. Looking at this function, I'm not sure either one's going to be easier than another. I probably, I don't know. I could use the quadratic formula, but I did that in an earlier video. So, I'll leave that to you as the viewer. What is going on? Here we go. To use the quadratic formula and see if you get the same answers. You can use the quadratic formula, which I'll abbreviate as quad form, on your own. But for practice, so you can have a reference video, I will complete the square with this ugly looking thing, because actually I see a couple things here that won't make this too bad. Alright, so first I'll complete the square. Alright, so quick reminder here, I need 1x squared. Right now I have negative 2 times x squared, so I'll factor out a negative 2 from my x squared term and my x term, which means I'm going to divide it by negative 2. So this becomes x squared, which is great. And then 8 thirds divided by negative 2. Remember that dividing by negative 2 is the same as multiplying by negative 1/2, multiplied by the reciprocal, which that's not so bad. This becomes negative 4 thirds. Alright, so dividing by negative 2, multiplying by negative 1/2, whatever you want to think about that, this middle term becomes negative 4 thirds x. What do we do with the constant? Get it way out of the way. Put it to the side, keep it outside the group. We don't need it to complete the square. So using a geometrical approach here, we have negative 2. And now my favorite part, completing the square with some geometry. Literally draw a square in here, and then let's clean this up a little bit. Make 4 regions. This region is going to be x squared, and now we have to take this middle term. It's just a fraction, but it's negative 4 thirds. Again, we didn't need to divide it by 2 or multiply a negative 1/2. We have to split it up into 2 regions. Just think about this. Negative 4 thirds cut in half. That's negative 2 thirds. Actually, I should be saying negative 4 thirds x cut in half. So negative 2 thirds x. This is negative 2 thirds x. So now we look at the dimensions. I'll change the colors for a little bit. X by x gives you x squared in here. And then if we think of this as row x, this column would need to be negative 2 thirds. So that x times negative 2 thirds gives you your negative 2 thirds x. Likewise, this dimension would need to be negative 2 thirds, so that when we multiply this row by this column value, we get negative 2 thirds x. And here we go. Now we complete the square. We need to add row times columns. Negative times a negative is positive. 2 thirds times itself is 4 ninths. Great. So we need to add 4 ninths. Let me copy down this 32 ninths. Alright. Biggest thing about completing a square, if we add it to keep it balanced, we subtract it. And actually, we didn't add it to a group. We added it to, this seems strange, but we added it to the opposite of 2 groups. So we need to multiply this by negative 2. Alright, always multiply by your a value. So let's see what we get. All this work just to find the zeros. Negative 2, maybe the quadratic formula was a better idea. Alright, you go back and do that. But here we go. This is x minus 2 thirds squared. length times width. And then outside here we have 32 ninths. I'll keep that. Negative times a negative is positive 8 ninths. Alright, which we got some more to simplify here. This is negative 2 times x minus 2/3 squared. This makes 40 ninths. Alright, so that's an equivalent form. This is now in vertex form. I took standard form, just a quick review. I took standard form and I completed the square to get it to vertex form. Now, to find the zeros, I set to 0 and work backwards. You go back and do this with the quadratic formula. Way simpler. But as review, as I said. So, take this function, which is, what do we call it, g of x? Yep, so this is g of x in a new form, an equivalent form. Set it equal to 0. Negative 2 times x minus 2/3 squared plus 40 ninths. And just work backwards. So x minus 2/3, then squared, then times negative 2, then add 40 ninths. So subtract 40 ninths from both sides. And what do I end up with? Negative 40 ninths on the left is negative 2 times x minus 2/3 squared. That makes a 0. I need a new page. X times negative 2/3 squared, then times negative 2. Undo that by dividing both sides by negative 2. Or dividing by negative 2 is the same as multiplying by a negative 1/2. I think that's going to be simpler on the left here. Negative times a negative is positive. This 2 and that 40 simplify. So we're actually left with 20 ninths on the left equals, those undo each other, x minus 2/3 squared. Keep working backwards, take the square root. We are in algebra, so both answers. And on the right, x minus 2/3. On the left, we got a little bit of work here. What's simple is the denominator. What times what makes 9. That's simply just 3. So at the top I have plus and minus the square root of 20, which I'll simplify later because that's going to be a little more work. Last but not least, undo this subtraction of 2/3 by adding 2/3. And I don't feel like scrolling down anymore, so I'll put my answer over here. So on the left, we have 2/3 plus and minus the square root of 20/3 as our zeros. These are the zeros. They are real numbers. They're not the prettiest, but we can figure out what they are. Let's simplify our answer. So simplify. I'm adding two fractions. Luckily they have the same denominator. That's pretty nice. So this just makes 2 plus and minus the square root of 20 over 3. Since the denominators are the same, we just add the numerators. And now the square root of 20 can be simplified as, let's see, 2 plus minus 4 times 5. Those are our zeros. The square root of 4 is 2. The square root of 5 does not simplify, over 3. And you might ask yourself, hey, there's a common factor of 2 in the numerator, but I'm also using my algebra sense, and factoring out the 2 isn't going to simplify with my denominator down here. So both of these answers are acceptable. This is typically what we would write, but if you're in the habit of factoring out, go for it. Notice that the common factor is 2. You can say this is 1 plus or minus square root of 5 times 2 in front divided by 3, and no simplification anymore, but either one of these. Alright, so there's matter of preference, matter of textbook, matter of teacher, so I'm showing you both. This is definitely, either one of these are the simplest forms. I typically believe that this is it. If nothing's going to simplify in your numerator and denominator, we usually just keep it of that form, but no big deal either way. No both. I'm not going to stress about it. So those are your zeros. Graphically now, we would use some technology. All right. Let me input this function. I don't have it ready to go, but we can do it really quick. So g of x is negative 2x squared plus 8 divided by 3 x plus 32 divided by 9. And if we look at the x-intercepts, they are approximations. Negative 0.82 or 82 hundredths and 2 and 16 hundredths. Where are those coming from? Well, let's go back to our answers. Quick. And these are the exact zeros right here. So I'm going to use the calculator feature here to approximate them. So I have 2 plus 2 square roots SQRT 5 divided by 3. And here we go. If we look at the graph, let me hide this 0. This should be an approximation symbol, but it's approximately 2 and with some rounding 2 and 16 hundredths. Hey, there it is, 2 and 16 hundredths. So that's that 0. This is an approximation, but this is the exact value. Approximation, exact value. 2 minus 2 square roots of 5 divided by 3. Approximation. If we grab 2 decimal places, we look at the third, does not round up, so negative 82 hundredths, and that's why it's showing up that way on the graph. So that's how you would find these graphically. The one thing I wanted to point out is the graph does obviously give you an approximate answer, doesn't give you the exact algebraic answer, but depending on the context, depending on the situation, sometimes the approximation is good enough, but no both. And that's it. So if you have any questions, please email me. Good luck.